But what if we have a non-homogeneous equation, or to be precise, a non-homogeneous linear equation? Say equation of the form y double dash plus pxy dash plus q as a function of x into y, and this is equal to r as a function of x. Now in such cases, what you do is we're going to find the solution of this part, considering this as homogeneous equation. So we're going to take y double dash plus p as a function of x into y dash plus q as a function of x into y, and we'll put it equals to 0, and from this we'll get a solution which we call yh. And then putting specific values of C1 and C2 in YH, we are going to get something called as particular solution. And we'll say, let this solution be YP. So in such case, what we'll do is we'll find YH, considering this first part, and then using specific values of C1 and C2, we'll calculate YP. Then general solution to this equation yx will be given by yhx plus ypx. So this is how we solve a non-homogeneous linear differential equation of second order. Now there are several ways to find it, and the first one is called as solution by undermined coefficients. Now what we already know is general solution of non-homogeneous equation is yx equals yhx and ypx, where yh is solution of corresponding homogeneous equation and yp is any particular solution of the non-homogeneous equation. Now though the general method of solving such problems is a little complicated, what we'll do is we'll start with a very special case, and this case is solution by undermined coefficients. So in this we have a second degree linear differential equation, and on the left hand side we have constants a and b. So equation will be of the form y double dash plus ay dash plus by, and then this is equal to some r as a function of x. Now first step obviously here will be to solve this homogeneous part, y double dash plus ay dash plus by equals to 0, by writing its characteristic equation lambda square plus a lambda plus b equals to 0, and then depending on the case we can write its homogeneous solution yhx. And this what's interesting is how to find yp or its particular solution. Now to find this particular solution, there are basically 3 rules, and this first one, it is called as basic rule. Now in basic rule, we have a table, and in this table we have some function rx, and with these rx we are given some special cases of rx, and against each case we are given a choice of yp. So we need to remember this table. So we have this table. So we have Rx, and then for each Rx, we have to write choice of Yp. Now the first one is, if Rx is an exponential function, some k into e to the power tx, we are going to choose Yp as some c into e to the power tx. So if it is an exponential function, we'll assume that exponential function is yp. We'll just change this constant. See, we have this second case when r is of the form k into x to the power n, and here value of n is 0, 1, 2. So basically n is any whole number. So if n is a whole number, then the choice of yp is, we can write cn x to the power n plus cn minus 1 x to the power n minus 1 cn minus 2 x to the power n minus 2 up to c1x plus c0. Say for example, if we have rx as x square, then we can choose this yp as sum ax square plus bx plus c. So if it is of the form x to the power n, then we can take it as a polynomial of degree n. Now this third one is, if we have k cos omega t or k sin omega t. So either it is k cos omega t or it is k sin omega t. Then in both the cases, we are going to choose this yp as sum c1 cos omega t plus c2 sin omega t. So we're going to take it as c1 cos omega t plus c2 sin omega t. And if it is of the form k e to the power tx cos omega t or k e to the power tx sin omega t, then we have to choose this yp as e to the power tx into c1 cos omega t plus c2 sin omega t. So we'll discuss it one more time. So if rx is some exponential function, then yp is simply c into that exponential function e to the power tx. If rx is some k into x to the power n, then yp is a polynomial function with constants of degree n. And if it is k cos omega t or k sin omega t, then simply it will be c1 cos omega t plus c2 sin omega t. And fourth one is, if it is k exponential cos omega t or k exponential sin omega t, then we want to choose yp as exponential function into c1 cos omega t plus c2 sin omega t. Now the first rule is our basic rule, and it says if rx is any one of these functions, then we're going to choose yp from this table. And then what we'll do is we'll find y dash p and y double dash p, and we'll put it in this equation to find undetermined coefficients to get a particular solution. So that's your first basic rule. Now the second basic rule is modification rule. Now modification rule says you have solutions in yhx, and if this yp, it corresponds to one of the solution of yhx, then in that case we want to modify this yp to xyp. So if it corresponds to one of the roots. Now if it corresponds to a double root, suppose here we have roots lambda 1 equals lambda 2, then in that case we want to modify this yp with x square yp, so on and so forth. So that's your modification rule. If yp is distinct, we have no problem. We are simply going to choose yp from this table. But if yp is same as one of the roots, then we want to take this yp as xyp. And if this yp is same as two of the roots in yh, then we want to write it as x square yp, so on and so forth. And then we have this third rule, which is called as sum rule. Now sum rule says if rx, it is not a simple function, but it is sum of combinations of these functions. So it is sum of combinations of rx. Then in that case we can choose yp as sum of combination of yp's. So suppose we have k e to the power tx plus some k dash x to the power n. So what we're going to choose is, we're going to choose this yp as c e to the power tx plus cn x to the power n, cn minus 1 x to the power n minus 1, c1x plus c0. So if Rx is sum of combination of functions, all you need to do is you need to take this yp as sum of combination of functions. These three rules, they are very important in solving differential equation using methods of undetermined coefficients, and these three tools, they'll come handy later as well. Now let us take up an example. Say for example, we are given that y double dash plus 9y, it is equal to 4x square, and we need to solve this second order differential equation. Now the first part is, we'll find solution to the homogeneous differential equation. So we are going to write y double dash plus 9y equals to 0. We can write lambda square plus 9 equals to 0. Now lambda is plus or minus 3 iota. Now we can simply write this yhx as c1 cos 3x plus c2 sin 3x. So that's your yh. Now we need to find yp. Now in order to find yp, we look at this rx. Now this rx is 4x square. Then from the table we know we can choose yp as sum ax square plus bx plus c. Now yp dash is 2ax plus b, and yp double dash will be 2a. Now yp is solution to this equation, so we can write yp double dash plus 9yp and is equal to 4x square. Now yp double dash is 2a and then 9. Yp is ax square plus bx plus c, and this is 4x square. So we can write 9ax square plus 9bx plus 9c plus 2a, and it is equal to 4x square. Now it's an identity in x, so we compare the coefficients. We can write 9a equals 4, or a is 4 by 9. Now there is no term of x, so basically b is 0, and then we'll have 9c plus 2a equals 0, or basically c is minus 2 by 9a, and there will be minus 8 by 81. So in this case, this yp will be ax square, and there will be 4 by 9x square, b is 0, and then minus 8 by 81. So that's your particular solution. So solution to this differential equation will be simply yh plus yp, and there will be c1 cos 3x plus c2 sin 3x plus 4 by 9x square minus 8 by 81, and that is the answer to this question. Now this we have simply used basic rule. Now we'll take another question where we are going to use basic rule with modification. Now here the question is, we need to solve this differential equation y double dash minus 3y dash plus 2y, and it is equal to e to the power x. Now first we'll find yh, and for that we'll write y double dash minus 3y dash plus 2y equals to 0. Corresponding characteristic equation is lambda square minus 3 lambda plus 2 equals to 0. So we'll have lambda is 1, and so this yh will be sum c1 e to the power x plus c2 e to the power 2x. Now we have Rx as e to the power x, and from the table we know if Rx is e to the power x, then choice of Yp is c into e to the power x. But the problem is e to the power x is one of the root of Yh. So now the modification rule says rather than taking y as c e to the power x, we are going to take Yp as c x into e to the power x. Now y dash p will be c, and this is x plus 1 e to the power x, and if we differentiate again, it will be c x plus 1 e to the power x. So there will be x plus 2 e to the power x. Now we'll put the value of yp, y dash p and y double dash p in this equation. So we can write y double dash p minus 3 y dash p plus 2 yp equals e to the power x. So it will be this cx plus 2 e to the power x minus 3c x plus 1 e to the power x plus 2c x into e to the power x, and that will be equal to e to the power x. Now this e to the power x we can cancel. Now this is, now we can take c common, so it will be this x plus 2 minus 3x minus 3 plus 2x, it is equal to 1. Now 3x will cancel, we get value of c as minus 1. So its particular solution will be minus x into e to the power x, and the solution to this differential equation will be simply yh plus yp. So yh is c1 e to the power x plus c2 e to the power 2x minus x into e to the power x. Now we'll take up an example where we'll use modification rule with double root. Now say for example, we're given a third order differential equation which is y triple dash minus 5y double dash plus 8y dash minus 4y, and is equal to e to the power 2x. We can simply write this as lambda cube minus 5 lambda square plus 8 lambda minus 4 equals to 0. Now one of the solution is lambda equals 1, so we can write lambda cube minus lambda square and then minus 4 lambda square plus 4 lambda and plus 4 lambda minus 4 equals to 0. We'll have lambda square lambda minus 1 minus 4 lambda lambda minus 1 plus 4 lambda minus 1 equals to 0. So we'll have lambda minus 1 and then lambda square minus 4 lambda plus 4, and there'll be lambda minus 2 whole square. So the roots are 1, 2 and 2. So we can write its solution yh is c1 e to the power x plus c2 plus x c3 e to the power 2x. Now here we have Rx as e to the power 2x, and for this Rx, choice of Yp is c into e to the power 2x. But the problem is we have a double root at e to the power 2x. So modification rule says we're going to choose this Yp as c x square e to the power 2x. So we have to choose it as c x square e to the power 2x. Now y dash p is c 2x square plus 2x e to the power 2x. Y double dash p will be c and then 4x square plus 4x plus 4x plus 2 e to the power 2x, which is c 4x square plus 8x plus 2 e to the power 2x, and then we'll find y triple dash p, and there'll be c, and there'll be 8x square plus 16x plus 4 plus 8x plus 8 into e to the power 2x, which is c into 8x square plus 24x plus 12 e to the power 2x. Now we'll put all these in this equation. Y triple dash p will be simply c 8x square plus 24x plus 12 minus 5, and y double dash, it is c and 4x square plus 8x plus 2 e to the power 2x plus 8 y dash p will be c into 2x square plus 2x, and minus 4y is c x square e to the power 2x. Here also we'll have e to the power 2x, and here also will be e to the power 2x, and this is equal to e to the power 2x. Now we can cancel e to the power 2x. We'll take c common, and then we'll have 8x square plus 24x plus 12, and this is 20x square minus 40x minus 10 plus 16x square plus 16x minus 4x square, and it is equal to 1. Now this is 8 plus 16, 24, and minus 24, so x square will cancel. Now 24x plus 16x, 40x, and 40x will cancel. Now this is 12 minus 10, which is 2, so value of c is simply 1 by 2. So our particular solution is yp is 1 by 2 x square into e to the power 2x. So now we can write general solution. So its general solution will be c1 e to the power x plus c2 plus x c3 e to the power 2x plus 1 by 2 x square into e to the power 2x. Now we'll take up an example where we only need this rule 3. Now suppose the question is y double dash minus 2y dash plus 3y, and it is equal to x cube plus sin x. Now first we have to solve for yh. So we have to solve y double dash minus 2y dash plus 3y equals to 0. So there will be lambda square minus 2 lambda plus 3 equals to 0. Lambda minus 1 whole square plus 2 equals to 0. So lambda will be 1 plus minus iota root 2. So this yh will be simply e to the power x c1 cos root 2x plus c2 sin root 2x. Now we need to find yp. Now here this rx is a combination of x cube and sin x, and we know that for x cube it's a polynomial of degree 3, and for sin x it will be a sin x plus b cos x. So we're going to choose yp as ax cube plus bx square plus cx plus d plus suppose p sin x plus q cos x. Now we find y dash p. So there will be 3ax square plus 2bx plus c and plus p cos x minus q sin x, and y double dash p will be 6ax plus 2b minus p sin x minus q cos x. Now we'll substitute these in this equation. So we can write 6ax plus 2b minus p sin x minus q cos x minus 2y dash p. So there will be minus 6ax square minus 4bx minus 2c minus 2p cos x minus 2q sin x plus 3y. So there will be plus 3ax cube plus 3bx square plus 3cx plus 3d plus 3p sin x plus 3q cos x, and will be equal to x cube plus sin x. Now we need to find the value of a, b, c, d, p, q. So we have 6 unknowns. Now first we'll compare coefficient of x cube. Now here we have only one x cube term on the left hand side and one on the right hand side. So value of a is simply 1 by 3. Now if we look at coefficient of x square, we have minus 6ax square and 3bx square, and there is no x square on the right hand side. We'll get 3b equals 6a. So basically b is equal to 2a. So value of b will be simply 2 by 3. So we have b as 2 by 3. Now we'll find coefficient of x. So we have 6ax minus 4bx and 3cx. So we can write 6a minus 4b plus 3c equals to 0. Now this is 6 by 3 minus 8 by 3 plus 3c equals to 0. So value of c is simply 2 by 9. So we have c as 2 by 9. Then we'll take its constant term. We have 2b minus 2c and 3d. So 2b minus 2c plus 3d equals 0. Now 2b is 4 by 3 and minus 2c is minus 4 by 9 plus 3d equals to 0. Now this is 12, 8 by 9. So value of d is minus 8 by 27. So value of d is minus 8 by 27. So we have a, b, c, d. Now we need to find the value of p and q. Now we look at coefficient of sin x. Now here it is minus p sin x, and this is minus 2q sin x. I think it should be plus 2q. Let's check. This is minus 2 and y dash is minus q. So minus 2 into minus q will be plus. So we should have a plus sign here. So we'll have minus p plus 2q and plus 3p. So there will be 2p plus 2q, and it should be equal to coefficient of sin x, which is 1. And if we look at cos x, it is minus q cos x minus 2p cos x and minus 3q cos x. So from here we get 2p equals 2q, that is p is equal to q, and if p and q they are equal, value of pq, it should be 1 by 4. So from here we can write this yp as ax cube. So it will be this 1 by 3x cube plus bx square plus 2 by 3x square plus cx plus 2 by 9x plus d minus 8 by 27 plus p sin x plus q cos x. There will be 1 by 4 sin x plus 1 by 4 cos x. General solution of this equation will be this e to the power x c1 cos root 2x plus c2 sin root 2x plus 1 by 3x cube plus 2 by 3x square plus 2 by 9x minus 8 by 27 plus 1 by 4 sin x plus 1 by 4 cos x, and that is the answer to this question.